Hello everyone. So, in this video, we are going to discuss about electric field. So, what is an electric field? So, the electric field is the force per unit charge. Force per unit charge. Q naught. So, suppose there is a charge Q at point A and at point B. So, between A and B, there is a distance x. So, the charge plus Q produces an electric field at B. So suppose there is a charge Q naught plus at B. So plus Q repels Q naught. The force Q F is equals to 1 by 4 pi epsilon naught Q to Q naught by x square. So now let's substitute here. E is equals to 1 by 4 pi epsilon naught Q into Q naught by R square into Q naught. So we are having 1 by 4 pi epsilon naught Q by x square. So here E is equals to integration of dE is K into dQ by x square. So here K is equals to 1 by 4 pi epsilon. So suppose there is a rod like this. It is uniformly positively charged. Its length is L and with a charge Q. Charge Q. So now we need to find the electric field at at this point. So which is at a distance of x. So to find the electric field at this point A, we will do E is equals to integration dE K into dQ by x square. So now let us take a small element dx. So and it so this elemental part is having a charge dq. So now we are going to discuss an important thing called linear charge density. Lambda is equals to q by L. So now this q by L is also equal to dq by dx. So now dq is equals to q by L into dx. Now we will substitute it here. Integration k into q by L x square dx. So the limits will be L plus x to x. So here it is at a distance of x and from this is totally L plus X. So K cube by L into 1 by X square dx into L plus X is equals to K cube by L minus 1 by X L plus X by X, that is K cube by L into 1 by X minus X plus L. So now, after this, we will get K cube by X into X plus X plus L as the answer. So now this is our electric field for this rod. So now let's go to a question. So in this question, we can, so now let's go through this question. So now here the same thing. The rod of length L carries a charge along its length. Linear charge density is uniform and is equal lambda. So here linear charge density is lambda. So here the length is L, and if we see here the length is L, this total length is L. So here X plus L is, so here the X plus L is 12. X is L. So in the previous question, we took X, 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 and in the place of X, here he took X equals to L. So here the electric field for this is K into Q by 2L square. So now if we want to find out the force, so here he is asking about the force on Q. So if we want to find the force, force E is equals to F by Q naught. So F is equals to E into Q. So F is equals to K into Q into dq by x square. So here F is equals to, now we need to integrate it. K into Q by x square dq is Q by L dx, that which is lambda dx. Here kq lambda will be outside and 1 by x dx. And here we need to take the limits from 2L to L. So 1 by x square dx. Now it is k q l by minus 1 by x 12 to L. So now here we will get k q lambda by 12 as answer. So that's it for today. So we will get on. So in the next video, we will discuss some more topics.